ready for takeoff.
I was just telling Craig that the first time that I ever gave a talk in public was an academic conference when I was a grad student, and I was similarly in the last session of the last day in a room that was this big or possibly bigger, and like exactly 3 people showed up. So thank you for being more than 3 people, and thank you for spending your time here this week. I really appreciate everybody coming out to be a part of the Ruby community. So thank you. Let's start by looking at some code. Ruby fans here? Let's look at some code. This is real code from a fake project. It's a side project that I do. It's a project tracker. If you, for some reason, follow my newsletter or blog, you may have seen me write about it. The important point here is that this is a project tracker. Everything in the tracker is a card. Every card has a status, and the status has been abstracted out to its own object. So we have a parent object, a parent abstract class called status, and a series of subclasses that are the individual status types: done, started, unstarted, attic, whatever. Every client of this deals with the abstract class, and obviously we have all of these concrete classes that have other functionality too. This is just sort of a simplified schematic of the problem. Now, the parent class defines a bunch of other services. It defines creation methods for each individual status. It defines strings. 2 strings for each individual status. It defines predicate methods for each individual status. And it also defines, this is the main mechanism by which we convert from the active record data structure to our status. It comes in here, so we have a case statement. Okay? And you can quibble about the various implementations of this, but let's assume for the sake of the problem that this is actually the business logic we need. And so my immediate question to you is, how does this code make you feel? To look at it, it kind of shows up on the background there. You've got these subclasses. You've got all of these predicate classes, the creator classes. Does this seem good? Does it seem right to you? Or does it give you that kind of unmatched parentheses, this is ruining my day, I need to fix this immediately kind of feeling? By the way, if you've seen talks of mine before, you will know it is extremely on brand that the only image I use is just a bunch of text. More to the point, the question is, or to put this in a slightly more like domain-specific context maybe, does this code have duplication, right? And in one sense, the answer is clearly no. If I want to find out, is this status done or not? Like, there is one place in the code and only one place in the code that has that information. But in another way, it kind of feels like it has duplication, right? So, like, what happens if the list of statuses changes? If we want to add a status to say that it's been sent to production, a deployed status, like, what do we need to do there? Lots of things, potentially. So let's talk about that. So this is a talk called In Defense of Metaprogramming. We'll get there in a second. My name is Noel Rappin. I work as a staff engineer at Chime Financial. There are several Chime people in the audience here. We would all be happy to talk to you about Chime or anything else in the world. You can find me at Noel Rapp and noelrappin.com, and I promised myself I would only get really self-promotional if I finished the talk in under 30 minutes, so we'll get there at the end. So I want to start with a definition to make sure we're all talking about the same thing. There is a formal definition of metaprogramming that has to do with changing behavior at runtime and is only sort of related to what we sort of think of in Ruby, the kinds of things in Ruby that we call metaprogramming. What we're really talking about here, and the way this is frequently referred to in the Ruby community, is magic. And my definition here of magic is anything in Ruby that is program behavior that is not specified like normally. Not specified the way somebody from another language would come in to know to look for it. So normal is a class definition with class, a method definition with def, normal dot syntax for method method dispatch, that kind of thing. And anything else we'll call magic. Ruby is designed to make magic very easy. And so we have things like define method. We have things like method missing. Both of these things allow you to create functionality at runtime without using the normal explicit def keyword. We have things like instance eval, which allows you to specify the relationship between a message and its receiver at runtime. Again, somewhat magically. We have all of these features that allow us to do this. And it might be like the old maniest old man thing for me to say, but there did used to be more magic in the world. Rails used to have these long method missing hacks, find by email and name, where the things were arbitrary and it could go on forever, and they were method missing, and they were wonderful and fun and completely made unnecessary once Ruby added keyword arguments. So we got rid of them. RSpec used to have an even more magical syntax. If you can imagine, people new to RSpec and can't imagine that RSpec was once like even more inscrutable internally than it is now. It was at one point, because it directly monkey patched object. And again, a syntax that had its advantages, but had a major disadvantage in that it triggered subtle bugs from time to time for no reason. And so we got rid of it. So I think in a broader sense, these are just specific examples, and there were reasons for making these changes. There were reasons why these things existed and reasons why they went away. But the claim that I want to make here, or the Ruby community has sort of pulled back from magic and from being proud about it, I think, as a thing that Ruby is. The very first Ruby community event I ever attended, maybe the second oldest man thing I'm going to say up here, the first Ruby community thing I ever attended was in 2008, and the first speaker was Dave Thomas, and he was speaking about metaprogramming and how wonderful it was that Ruby had all of these wonderful tools, and he specifically said that the problems that people have with metaprogramming are not technical problems, they're people problems, solvable with training. And I think that for good reasons and for bad reasons, I think over the intervening, 15 years, the Ruby community has decided that these are in fact technical problems. And we hear from people within the community, from people outside the Ruby community, we can't do this, it's too complicated. It's too hard to maintain. Developers from other languages won't get it. We won't be able to train people. And all of that is true to a point. It can be complicated, especially when misused. It can be hard to maintain. Certainly true that developers from other languages have a learning curve. But my argument here is that we've overcorrected, that we've gone too far in the other direction, and we are too defensive about the things that Ruby can do. And as I have put together this talk, as I've been working on this talk over time, I have felt this tension in myself as to how I want to present this. Do I want to come out and be like the hot takes guy and be like, metaprogram everything, metaprogram all the things, and just like scorched earth and everything, metaprogramming is the best, everything else is the worst. Or my other instinct is to be defensive and put everything in maybes. Don't talk about the weird stuff too loudly. The other languages might hear you. Maybe this stuff is better sometimes. And so I feel this tension in myself, and I don't really like it, honestly. But I want to talk about it, and I want to talk about these things that Ruby does well is really good for, and when they can really be used super effectively within your code base. So to put this kind of another way, or to talk about the way that Ruby is perceived, this completely to scale, deeply thought out, very well researched chart suggests that there is a small group of things that is sort of encouraged in Java, and for Java, say any sort of enterprisey language or tool set, doesn't really matter. There's a subset of things that are encouraged there, and there's a larger set of things that is encouraged in Ruby. And the attitude that I have experienced sometimes over the last several years, is the idea that because Ruby allows all of those extra things, it's not serious. You can't do serious work in it. And once upon a time, I was doing training. I used to do training when I worked at Groupon, and I used to do internal training. And for whatever reason, I was training developers in Ruby who were never, ever going to use Ruby. But the onboarding had them go through 4 days of Ruby training, which they loved and I loved. And I remember very clearly bringing up String Inquirer, one of the really magical Ruby stuff, and having people laugh. And not in this is delightful programmer happiness kind of way, but more in here's a nickel kid, let me know when you got a real job, kind of way. And there's this sort of sense that because you can do these very dynamic things, that it is somehow preventing you from being able to do real work in Ruby unless we don't do those things. There's sort of the related claim that going outside that bubble only has costs and never has benefits. And you sometimes see this specifically with static typing. The claim that being stricter is always good. You will sometimes see like advantages of static typing without seeing a corresponding disadvantages of static typing. I refuse to believe that of all the things in programming and development that have trade-offs and good things and bad things, that static typing and not doing dynamic things is the only thing that has costs and never has benefits. So I want to say, like, let Ruby do what Ruby is good at. And what do I think Ruby is good at in this context? Ruby is extremely good at managing a certain kind of complexity. What do I mean by complexity? If you go back to that original code, if you can remember it from 10 minutes ago, if you go back and you look at this code is not structurally complex. If you run it through a computational complexity analyzer, which I did not do, it will probably not score very high. It has no loops. The only conditional is that case statement. It has a bunch of one-line methods. It is generally like, on a line-by-line basis, this code is very easy to understand. At the same time, this code is very organizationally complex. There are several concepts in this code that are actually related, that this code makes no effort to enforce that relationship, right? So there's a class name, there's a string representation, there's a class method, there's a predicate method, and there is the branch in the at statement. And those things are all tied to each other. They all have a relationship, but this code does not. This code leaves that relationship implicit. And my argument here is that makes the code more complicated over time. If I were to come in and I wanted to add a new deployed status, there's nothing preventing me from making the class name deployed class and the string representation production and the predicate method deployed in production question mark and all of that stuff. And over time, that kind of inconsistency can make this code base very hard to work with, even though it is not like notionally complicated. I forget which one is complicated and which one is complex. I always get that wrong. It's neither and both, right? Over time, this code base just exposes a lot more surface area of the domain to the developer in a way that my claim here is, in a way that will make it harder to work with over time. So let's look at some other code. Here's a way around this, one way. This way, in this case, I'm not replacing the subclasses. The subclasses still exist, but I've got a list of all the statuses on the top line. They're a list of strings. And then I'm looping over each of them, and I am converting each string to a class using the Rails constantize active support method. I'm defining the class method, the creator method, to create a new method of that class. I'm defining the predicate method using define method. I am defining the toString directly as the string status, and then I'm using the app method and using send to define the app method in terms of the other ones. Is that clear? Clearish? Mud? Mostly? There's another way so this unifies all of the concepts except the relationship between the class name and the status name. But we can actually do a little bit better in Ruby by using Ruby's hook method. This is a version of this code that uses Ruby's hook method, inherited. If you don't know what inherited does, inherited, every time a subclass is loaded, created at load time, it calls this inherited hook of the parent class with the subclass as an argument. So every time I define one of those done statuses, started statuses, whatever, this inherited hook is called, and it takes the subclass, and we extract out the string, and we do the same. We create the same methods. We create the class method, we create the string method, we create the predicate method, and we create the app method. Okay. So this actually unifies all 5 of those concepts in one piece of the code. If I want to create a deployed status, all I need to do is create a class deployed status and make it a subclass of status, and everything else falls out. I get the predicate method, I get the class method, I get the toString, I get the @ everything comes together. Okay? Now, this code is clearly more complicated than the original code, or complex. It's one of the two. Right? If you look at this, I've got a loop, I've got some fairly advanced Ruby methods in terms of define method. Like, you need to understand, I'm not shying away from the fact that this is a higher bar to entry piece of code. But at the same time, it has fewer independent concepts from the outside. If I need to create a new status, I have much, much less work to do. I have separated data and logic in a particular way, that they had this set of structural data in terms of what all of these statuses are, and all of this logic in terms of how those statuses play out in the actual API of the code, and I've now separated them. So that if adding a new status, the whole API falls out. This argues to me that there are at least potentially costs here of not metaprogramming. There is this particular kind of complexity that the not metaprogramming solution has. The original solution is also more lines of code, more code to maintain. Again, not even just for bugs, but for the kind of repetition or inconsistency, for the kind of inconsistency that you might get if developers, after a certain amount of time with developers adding potentially new statuses or whatever. And I understand that the individual logic in this case is simple, but if you sort of extract this to, say, shipping costs or tax law against 50 states, like, you can see a case where these inconsistencies from structure to structure could really build up, and that the metaprogramming is a way to get them under control. So, hopefully, I have convinced you that this is a reasonable use of metaprogramming. If I haven't, I'm sorry. We're going to assume as though I have. But I do want to talk about how to convince your skeptical coworker that you can do this, that this is a valid thing to do in your code base. This is not just a technical problem. And I think, understandably, the first thing that you need to do is really convince yourself that it's a good idea. And in this particular kind of metaprogramming that I'm talking about here, we're talking about answering a few questions in advance, like, is the code structure driven by external data? That's true here. It's also true for things like active records metaprogramming to unify database columns and attributes does the same thing. The code structure is driven by internal data. Rails routes does the same thing to enforce consistency with metaprogramming, to enforce the consistency of URL patterns to controller methods. Like, all of those things have structure that's driven by external data, and therefore, to my mind, are really good candidates for metaprogramming. Can the magic enforce the kind of consistency that you want in your code? Before Rails had resources, you had sort of a free-for-all in terms of what the names of the methods were in individual controllers, and it definitely added to the complexity of working with a Rails code base. Is the code easier to use from the outside if you're the metaprogramming version? In this case, a user of status shouldn't care one way or another, but somebody who's working on status, it's probably easier to work with, and it's definitely easier to change, or at least to make a certain kind of change. So from there, when you're trying to convince somebody, I think, who is skeptical of this, I think it helps to come in humbly and not hot and not with the metaprogram, all the things waving your arms, but to understand the concerns that they will have. And some of the things that are really commonly raised as concerns here are, how do we know it's going to be correct? How do we know that people are going to be able to read this? How will we be able to discover it? Will our tooling work with it? Will people be able to search for it? Like that is these are real, genuine concerns that I don't want to minimize. I think we want to be able to mitigate them, but you have to understand, in order to affect this change in your code base and to get yourself to the place where you can use these tools effectively, you have to be able to talk about the trade-offs here and to talk about these genuine concerns of readability, findability, and that kinds of things. There's a specific case argument here where the abstraction is such that the argument of I won't be able to search for this thing becomes sort of invalid because the metaprogramming abstraction is such that you won't need to search for that thing. I don't really know how Rails handles attributes internally. I just know that it matches the database table. It's not something I need to understand to be able to use a Rails class. I think this is true in many cases. In my experience, it is a very, very hard argument to make to somebody who has not used this kind of metaprogramming code before and is like very comfortable with the abstractions that already exist. The idea that the program structure might make you not have to think about a level of abstraction, I think is a very hard sell the first time through. Later cases, you might be able to make that case, but the first time through, I think it's challenging. Testing is really important for a couple of reasons. Number one, obviously, it proves correctness. But if you write the tests to be examples, it also helps with the discoverability and readability issues because you can point people to the tests as examples of how to use the code and of the range of the kind of behaviors that you're metaprogramming. You need to document it. Like, this is always true, but it's especially true if you're metaprogramming, and it is especially true if you're metaprogramming to a group of people that are less familiar with some of these Ruby code structures. Specifically, if you're using define method, you need to have a comment that shows a sample version of the method. So I didn't include these, obviously, in the sample code bases, but you can show here's the predicate method with a sample version of the predicate method. All of these comments will make the code longer, which is fine. We're not metaprogramming to play code golf. We're metaprogramming to simplify the amount of concepts you need to keep in your head. And in this case, the documentation will simplify that even further. If you do it right, it will also manage, excuse me, it will also manage some of the searchability constraints because the comments will have some of the search items. In some cases, you may have to give up on some of the IDE issues, and that is a potential problem, especially if you are used to static languages and you're used to editor support for static languages. Obviously, that's a loss here. Like, we want to make this simple enough that it overcomes that gap, but you can't pretend that gap doesn't exist. If you're using method missing, you need to have parallel it with Ruby's respond to missing, and again, also have a comment. Here's a version of the method. Here's a version of that code that uses method missing for the predicate, and again has a sample version of what a real version of this method would be like. So you really do need to allow for discovery. It's a genuine concern that we need to mitigate. And also, if you're introducing this stuff into a code base, especially a code base where people might be skeptical about it, you need to be prepared to teach it. You need to be prepared to be the local expert on it for a while. And that means that you need to be comfortable with explaining it to people. You need to be comfortable with pairing with people. You need to be comfortable with guiding people to why it's the right thing to do, when it's the right thing to do, when it's not the right thing to do, code review, that kind of stuff. Like, if you are bringing this in to some extent, you're taking an expert role, or leadership role, and you need to sort of own that. This can be fun. It can be fun both to use this code, both to write this kind of code, which is like the strength and the weakness of it. Like, it's fun, so we sometimes do it too much, but it's also fun, so we enjoy doing it and we enjoy talking about it. And like, I think it's worth remembering that this can be fun, and it should be fun on some level. To summarize, let Ruby do what Ruby is good at. Metaprogramming is really good at reducing a certain kind of complexity, particularly where you can cleanly separate the structure of the code from the data that's driving that structure. Stricter is not always better. Sometimes it is just stricter. I have talked extremely fast because I did this about 10% faster than I expected to, but I have a couple, therefore I get the promised self-promotion. This is version 5 of the PicX book, Programming Ruby. It is available now in ebook form for all of your favorite ebook formats. It is about 2/3 of the way done. You can get it at that URL, and with that coupon code. The coupon code is good, I am told, through mid-December, through December 15th. So you don't need to go out and rush and do this right now. And it's not like we're going to run out of ebooks. So you have time on that. The book's about 2/3 done. There should be a print copy coming. I would imagine spring. I'm hoping April. We'll see how that goes. There's a lot of logistics involved in that I don't control. My name is Noel Rappin. You can find me on Twitter at Noel Rapp and on Mastodon at Noel Rapp, Ruby Social at Ruby Social. NoelRappin.com is, where you can find my blog. You can sign up for a newsletter. The newsletter is sadly dormant right now because every time I try to cite something from the newsletter, my brain says, why aren't you working on the book? But once the book is done, it should come back. I work at Chime Financial. Thank you to Chime for sponsoring both this conference and my trip here. Thank you all for coming out and being a part of this community. Thank you to the organizers and the people who make all of this happen. And thank you for your time.